oxygen. Okay, this is most useful in hydroponics. Dissolved oxygen, right? So remember, in hydroponics, you don't just give plain water. You give water enriched with what? Nutrients, but then the water should also have enough of oxygen in it, right? The solubility of oxygen is very less in water. There are multiple ways you can enhance it. Remember fish tanks, aquarium, there is one big fish tank outside. Usually in fish tanks we keep a bubbler. The air is bubbling all the time. Why are we using a bubbler? It adds oxygen to the air, right? That's why we're doing it. Same thing in hydroponics. If you are recirculating the solution, the reservoir should have enough oxygen, and this sensor will tell you the percentage of oxygen. Okay, 10 parts per billion is more than enough, but I don't know what units it measures. These are a little bit older equipment. You know, the ones that I've shown you handheld ECPH sensors, you can just dip it in, then you get a quick measurement, right? But these are the ones that are probably from 1970s, that range from time, okay, 1970s, 75s, but they still work, they're robust, rugged, right, those days. But let them power it up. But in the meantime, what we will do first is, we will do the pour through. The output of the pour through is a leachate, and that leachate we're going to give it to him, and he is going to show us the EC and pH of that. But what we're going to do is, we have two parts, right? We have two parts. In one part, we'll apply small volume of water, another part we'll apply a lot of water and see what happens. Okay. The other disadvantage we have is that substrate is clay substrate in the part, not soilless substrate. But we'll deal with that. It might take a little longer for the water to trickle down and get collected in that saucer, especially because it's a clay. But I think they are moist. Clay, na? Soilless substrate. Soilless? So this is soilless substrate, so that's easy. Okay. All right, so this is regular soil, right? So that's why it looks like clay, that's what I thought. So it's not soilless, it's not peat medium. Regular soil, yeah, that's okay. It may take a little longer for the water to trickle down, leach out, which is okay. So our assumption is that these two parts are at container capacity, right? That's what they did. They took the parts outside and poured, I'm guessing, a lot of water to just bring them to container capacity. Meaning, if you add more water, it's going to push down, trickle down.
Because there were cracks from the sides.
Excuse me.
Compact, so it was taking drop by drop.
Okay. Okay. But we have these parts. So what we're going to do is, we're going to create two treatments. In one part, we're going to apply just I would say 100 milliliters of water. 100 milliliters of water. In the other one, we'll apply 200 milliliters of water. Okay, and let's see how much leachate collects in both cases. Maybe it may take 5 minutes or 10 minutes. We'll wait until, we want to wait until all of the leachate comes out and gets collected in these saucers. After they get collected, we'll transfer into those two beakers, and he will use the probes, and he will measure pH, a temperature. So you see that every probe comes with a temperature sensor. So this is a thermistor, right? And the reason for that is, these older ones probably need to be compensated for temperature too. The newer ones have an automated temperature compensation. I do not know. I didn't read the manual for this one. But if when you read the manual for these, you will find out whether they're temperature compensated or not. But all of them, you notice there is a temperature sensor along with an electrode. Okay. You can probably spend some time. In the meantime, couple of you, please make sure you add 100 ml here, 200 ml here, and let it slowly leach out. But you all can come and take a look at these three, read the units, read what they are measuring, what are they for, and what type of probes do they have, all of that. But make sure, you know, these are probably expensive units, so avoid touching them as much as you can. That I do not know. आप बता सकते हैं कि वो जो so they क्या calibration solution है आपके?
सर pH के लिए तो
4 and 7 is it? Okay, so 2 or 3 point calibration. and EC के लिए आप वो pH EC के लिए
KCl solution.
KCl. So potassium chloride, standard potassium chloride, which will have a known molarity, and from that you actually calculate the electrical conductivity too. कितना number होता है KCl के calibration per
Normally it is 1.41 at 25 degrees Celsius.
KCl?
KCl.
Maybe that's what they're looking at. Okay. So again, it's been calibrated. So these are calibrated sensors. So you're using the calibrated sensors. Okay. One way to quickly check calibration is you can also use RO water. If there is an RO water in this building, reverse osmosis water. I don't know, they may have added some minerals in it. I don't know about that, but the RO water should have pretty close 0 EC. Can we believe it? Okay, so he says he has RO water. We can also test that. So RO should show 0 EC, right? Close to 0, at least close to 0. Okay. But पहले let's add water to those parts. Just 100 ml and 200 ml. How do we measure that? 100 and 200. It can be any water at this stage. That's 250. How do you do half of that? So 120 and आधा करो. Yeah. आप इनको ट्रांसलेट कर सकते हैं, तो आप जो क्या कर रहे हैं हम उसको प्लीज बताइए. फोर थ्रू मेथड का कुछ एक्सप्लेन कीजिए उनको. उसमें पानी आएगा और लीचेट कलेक्ट होगा वो पीकर में, उसके बाद वो मेजरमेंट्स करेगा. Yes, over there. One 125, right? Half. नहीं, एक में 125 half, दूसरा में 250. So पूरा uniformly all around. Because you want to collect water from all pores and also apply slowly. बाहर आ रहा है. What we will do is let it come out, but after it comes out, we will measure it again. If more water came out than what you applied, then we have a problem. But let's see. Let it come out slowly because it's clay soil, right? So उसमें कितना है और इसमें कितना?
So this is 250 and this is 120.
And so that's why you see more there, right? Okay. But let give it for 5-10 minutes. But in the meantime, can he explain to you about these three sensors?
हाँ, आप थोड़ा बता दो इसके बारे में हम लोग.
सुनिए आप. आप आइए.
नहीं ये तो सब हिंदी वाले हैं. अरे उनको नहीं बताना है. ये pH मीटर इसको पहले कैलकुलेट करना होता है. इसके लिए तो बफर टैबलेट आती हैं या कैप्सूल आते हैं.
हाँ.
तो इसको 100 ml में वो एक कैप्सूल या एक टैबलेट इसको जो है डिसॉल्व कर देंगे. तो 3 सॉल्यूशन बनेंगे 4, 7 और 9.2 pH के. उससे इसको सबसे पहले कैलिब्रेट करना होता है. मतलब जैसे आप इसकी रीडिंग सैंपल लेंगे, इसकी रीडिंग सही आ रही है. उससे पहले इसको कोई एक स्केल भी तो देंगे ना कि कहाँ पे आएगा उसका रीडिंग. कैलिब्रेट करने के बाद फिर सैंपल इसको सैंपल में डिप करना होता है और यहाँ पे पीएच दबाएंगे, यहाँ पे पीएच की रीडिंग आएगी। अभी कोई सैंपल नहीं है इसलिए मैं उसको प्रेस नहीं करता, अभी स्टैंड बाई कर रही है।
अब एक बॉटल में आरओ वाटर उसका पीएच रहता है स्टिल, नहीं जो भी वाटर है उसको दे, we'll measure EC pH for that water, all these things as he's showing. आपको सामने आना पड़ेगा देखने के लिए।
यहाँ पे दो ऑप्शन है, एक तो ऑटो है, एक मैनुअल है। अभी ऑटो पे है, ये ऑटो पे आ गया।
7, 6.87, 6.19, 6.99, close to 7, yeah.
9 और 9 के बीच में फ्लक्चुएट।
So the आप टेम्परेचर प्रोब को भी जरा दिखाइए। वो जो टेम्परेचर प्रोब है ना, वो मेटल वाला तो टेम्परेचर प्रोब।
ये तो ये दिखा नहीं है।
It's okay. You will probably, the other one is working. Every probe has a temperature sensor, you see.
सर दोनों सेम ही है, मिनरल वाटर एंड
Same or similar? Exactly same?
Exactly same. Both are fluctuating between 6.98 to 6.99.
Okay.
ये मैनुअल में थोड़ा दिखा रहा है, ऑटो में अभी इसको दिखा रहा है।
मैं पानी लेके मैं पानी बोतल आरो का है नॉर्मल वो लेके
आजकल कोई भी आरो बिना मिनरल के नहीं होता।
तुम्हारा इसका आरो नहीं है ना, टैप वाटर है ना, वो लेके आना ही, वो फिल्टर से मतलब
इसको दोबारा एक बार देख लेते हैं। इसको भी जाओ बोतल में मैनुअल में कुछ अलग दिखा रहा है, ऑटो में कुछ अलग दिखा
फिर ऑटो में देख लीजिए।
रहा है।
ऑटो में दोनों का सेम आ रहा है।
Auto it is showing 6.98.
ऑटो में डिफरेंट है और मैनुअल में डिफरेंट।
What is R2 and what is manual mode?
One is automatic one and other one is manual.
What is automatic means?
क्या मतलब है इसमें?
आप EC का मेजरमेंट भी करवा दीजिए।
ऑटो ये है ना कि ऑटो जो ये सॉल्यूशन इसमें लगाएंगे, जब ऑटो पर करेंगे तो वो जितनी भी रीडिंग होगी वो उसको रीड कर लेगा। अब मैनुअल में ये है कि सपोज अगर 4 की 3.8 आ रही है तो हम उसको 8 बढ़ा सकते हैं, और ऑटो में हम 8.8 है तो रीड है कैलिब्रेशन के साथ।
Oh, calibration के बाद, I see. So it adjusts automatically. So जो भी मैनुअल है ना वो उसको यूज कीजिएगा। Auto is used during calibration, but during probably measurement time you have to use the manual.
मैनुअल जब हम अभी तो ये ऑटो पता है, ऑटो की रीडिंग ऑटो की है, मैनुअल दोनों की अलग आ रही है, मैनुअल में अलग आ रही है, वो वैसे कैलिब्रेट के लिए है, रीडिंग के लिए ऑटो ही कैलिब्रेट करेंगे उसके लिए
उसको यूज मैनुअल यूज करते हैं, ठीक है,
रीडिंग के लिए
ऑटोमेटिकली इट हैज टू,
के लिए ऑटो ही
ठीक है, फुल ऑटो ही ले लेंगे। अब आप वो ईसी कितना हो गया उसको, पानी का ईसी तो बहुत कम होना चाहिए, देखेंगे कितना है।
सर टेम्परेचर कंपनसेशन का है ऑटो और मैनुअल का।
ऑटो में खुद टेम्परेचर कंपनसेट करता है।
Sir, in this manual mode, you need to manually measure the temperature of your sample solution
And then
using a
adjust.
separate thermometer.
And then adjust it.
And in auto mode, in this mode, the pH meter is connected to a temperature probe.
Yeah. So EC का units क्या है?
ऐसी Simon thermometer.
No, देख microsiemens दिख रहा है मेरे को. Microsiemens, right? Microsiemens not per ppm or ppm. So ppm is different. ppm is parts per million.
Microsiemens per ppm.
Yeah, but it's not dividing it. No, it's not. You get two both measurements.
Microsiemens
R. Slash is forward slash means R. You can get both of them there. But what do you see for microsiemens? How many? What is the number?
248.9.
It's microsiemens.
कौन-सा चेंज कर दो सेम और ये है टैप वाटर।
Please test that. They have tap water, so you test it. Yeah, EC will be much higher there. Yeah. You can test that. You should get higher EC for that. Oh, she's gone out. Okay.
We have to note this reading.
No, we will do with our plant samples, but this is just trying to tell you. Actually, he has tap water. You should have higher EC. You can test it. आप इसको हिंदी में बता दीजिए.
5.1.
ये वाला टैप वाटर
टैप वाटर बैलेंस का नहीं हो सकता टैप वाटर का भी.
But they treat the water, right?
I see. Okay. So you have to use auto because in the auto mode, I just learned that somebody told me the temperature compensation automatically happens.
But sir, it is giving same reading in every kind of water. In auto. 6.9 stuck at tap water, RO water, everything is.
It's not working.
Yeah.
Why don't you use the EC meter and see if it is working? If you get a different measurement for the RO water and the tap water, then that is working. You should get a higher measurement for the tap water.
मतलब ये लिंक नहीं करेगा तो यहाँ पे पता चलेगा यहाँ पे आ रहा है यहाँ पे ये रेड है
चलना चाहिए ना.
नहीं ये नहीं वेरी करता है बस ये
EC measurement.
इसी चेक किया ना
हाँ, yes, yes. हाँ, वही EC.
ये टॉप ज़्यादा है सर टैप
How much?
63 62.9 62.9
62.
112.
Fluctuate a lot. So what are the units? Microsiemens? Millisiemens. And then what is the number you're getting?
fluctuating currently at 61.7.
No, that's too high. That's not correct. Calibrate nahi hua.
51.7.
It's not correct. Is it microsiemens? Then maybe makes sense. But if it is millisiemens, 61 is like too concentrated. See, that's the importance of technology. Put it, you get a number in the newer generation, and if you're dealing with dinosaurs like that, forever.
It's like lower the efficiency of
Fine.
the light of
Okay. Unfortunately. No.
actually when you were educating on the EC meter.
No, I don't need to know the reasons.
I want to tell you.
Probably tickled you.
No, one of my friends, like we had a project where we used the EC meter. We had to use that in the solution used on the root of the plant and submitted the file to the professor. So that connected the experience came to my mind and I immediately got into it. I'm really sorry for it.
It's okay. That was momentary.
I was so happy that for the first time I'm actually getting the concepts right.
नहीं सबको हंसाओ भाई कोई प्रॉब्लम नहीं.
I was so interested. Whenever we go back home, I try to prepare the questions for the quiz, and all. That's why I was coming to you every day for that.
No worries. So let me ask you, do we have problem with EC and pH measurements? I hear that the pH is not changing, regardless when you move from one beaker to the other beaker. Is it like 6.99 and all the time? That means the sensor is not working. Number one. What about the EC? The problem, huh? It is changing, but what I want to know the units that you're measuring. If it is microsiemens, that tells that the water is really pure. Very little, 0.006. If it is millisiemens, it should be 1.5 to maximum 0.5, 0.7. If that water has 61 and you drink it, straight go up. It is probably not calibrated, or it's calibrated way many months back. I do not know.
So maybe this is for soil or something else.
ऐसा कुछ नहीं है और
So if you are using the water from that bottle, drinking water, the EC should be very low. They will add little bit of minerals, but still you should not go above 0.5, 0.6 for millisiemens per centimeter. But if you're showing 60, 70, sorry?
260.
Yes, I think it is microsiemens because that makes sense. It's like 0.26 millisiemens. But I do not know if it is showing microsiemens or millisiemens.
on the checkbox there, it is blinking in the millisiemens.
Blinking?
The
Or
light is blinking.
light is there. Can you change that between micro and millisiemens and see?
When we switch to conductivity to some other unit, this light goes to
For TDS measurement,
TDS should also.
then what is the unit this will show?
AI, huh?
so we can cross check it with this leachate we have collected.
Sorry?
The leachate we have selected in that.
We should check now. Yeah.
For the
That's
cross, for the
now that you have seen the equipment and you know the problems. Let's measure that anyways for the two and let's see what happens.
MS stands for milliseconds, which is a unit of electrical conductivity. It's often used to measure the total dissolved salts in water.
Okay, so it looks pretty high. Do you think we can calibrate this equipment anyway?
Yes, it's definitely possible to calibrate the equipment. The process can vary a bit depending on the specific model, but it usually involves using standard.
उसको कैलिब्रेट करने के लिए KCl सॉल्यूशन चाहिए 1.41 कंडक्टिविटी का डेसिसाइमन पर मीटर.
केमिस्ट्री लैब चलेंगे.
So it's okay. Looks like we have, you saw the equipment. This is how the older ones used to look like. The more newer versions have both EC and pH combined into one small. The one that I showed you, it's about that size, just that size. So next week, maybe around 6th or 7th, we're going to have a Zoom call. A couple of my students will be doing a Zoom call on this. You can see them. One of them speaks very good Hindi. She is from Jammu and Kashmir. The other student is from South Korea, but both of them will show you all the sensors and automation. So you will see them anyways. You will see all those sensors and how they can be used. They will show you with a camera on that. But for now, for today, why don't you finish up what you started? Why don't you collect the leachate from 125 ml addition and 250 ml addition? But first, what you are collecting. If you have collected all the again down there, that means we have applied too much. Let's see how much is there and then let's measure it. Whatever it is, you should see a difference. But you get the big picture, how it is done. Yes, I think we can throw it away.
Sir, actually, still in the laboratories, these instruments are only available.
Yeah.
The newer model of these, we have still not shifted to these portable ones.
Huh.
खराब हो जाएगा वो.
So इससे बात कीजिए एक मिनट. If he's okay, you can set that EC value, whatever it's showing, to 0. Okay, assuming that is RO water, right? It may have some minerals, but let it set to 0. So that's, you are now calibrating, right? You are calibrating that instrument, but you should be okay with that. Make sure that he's okay with that. Okay, and then what about the other one? 250 came out.
Is that right or
That's okay. I think we probably fill that. We should be okay. Don't worry too much. But let's see how much comes out of the other one.
कंपेयर कर लेंगे ना उससे, क्योंकि वो उस वाले की वैल्यू सही नहीं आ रही इसमें.
क्या देखना है? सैलिनिटी देखना है.
हाँ, सैलिनिटी कंडक्टिविटी.
Salinity is total dissolved salts. We don't want that. We are looking at EC. And then measure the 125 ml and 250 ml. So here we are making an assumption that that bottle you use is pure RO water and there are no minerals, but it could be slightly wrong, but we are making a simple assumption. Okay. आप just EC measure कीजिए. pH का probe का doubt है मेरा. Now use that in 125 ml. Okay.
कुछ एयर के ले लिए
Change भी नहीं हो रहा है.
तो आप हर एक ले लेंगे तो वो कैलिब्रेशन हट गया ना रीडिंग दे वो तो मैं पहले आपको नहीं बोल रहा था.
I'm sorry, what is it?
So he's saying that we've
not
changed the
calibrated.
calibration, so it will not give the value of this one.
No, you just changed calibration, so you should get back to measuring mode now.
अब हमने उससे कैलिब्रेट कर दिया ना तो तब तो देना चाहिए क्या पहले हम उससे KCL से कर रहे थे हमने हम इससे कर
But that's the. I think it's not working.
We can take these two samples and somebody from either sir can go and take the reading.
You can also do that. You can also do that if they allow you. I do not know.
Sir, because
If you know, if anybody knows that, they can.
sir, in those samples के लिए आप कौन से देख लीजिए ना.
Please tell him that it's not working, so it's okay. Thank him. Thank him, and then. Otherwise, it's just waste of time.
कोई बात नहीं खराब नहीं करेंगे है स्कूटी मैं हूं यहां मेरे पास है स्कूटी जीरो ही दिखाएगा
ठीक. So, now we'll leave it there because I think. Thanks for showing them. Appreciate it because they have at least seen what the EC pH sensors are. हाँ, very good, very good. हाँ. इसको please help him so he can pack it up. Yeah. हाँ?
आप पी लीजिए
नहीं कोई नहीं
अब we can pack this up because ये जो काम नहीं कर रहा है ना इसलिए we can use that. But why don't you please help him so we can.
इसको भी हटा लो
But keep your no where is 125, where is 250?
ये वाला पानी.
So this is what?
So this is also the 250 ml, 125.
This is 125.
125 ml.
Okay, so the other one they haven't yet added, so why don't you get it into the beaker? The 250 is still in the.
हाँ, मैंने दूसरे वाले से निकाल दिया.
250 कहाँ है?
वो सर
उसको बीकर में ला.
So in the newer meters, only one rod is there for the EC.
No, what happens is there's a bulb. Bulb itself is an electrode. Bulb itself is an electrode. It gets charged. And inside there will be a tiny rod or a wire. That is the other electrode. So cathode and anode. That's how the technology is. Yeah, even here too you can see. You see the bulb down there. In the middle you can see one. Oh. It's broken. A bulb broke. This is broken bulb. That's why it's not working. Why don't you show everybody how the broken bulb looks? Okay, hi. Okay. So why is this is light in color? Maybe the fertilizer was less in the other part. Okay.
That is used in that pot, so that the soil also came along with the water.
Well,
The pot was broken.
okay. Okay. Or we'll keep it here. So I think the bulb was broken in that EC. I didn't see the pH, but once you have a broken bulb, it looks like a very old one. They haven't opened it for a long time. It came in packing actually, so it's probably they haven't looked at it. Possible. I mean, but now they have to replace the whole probe, right? And they may not even find that model anymore. So that's the problem. So maybe they are not using it. That's been kind of kept aside.
Sir, we had a similar one, older one in our laboratory, but once the probe was not working, we changed the model.
Good for recycling. Throw it away. You should never keep old stuff that doesn't work. It is only going to add more money, expenses, waste of time, waste of space. Just recycle it. More efficient. So one concern I have with these two is we have two parts, but what we don't know to begin with is how much fertilizer was there in those two parts, right? They could be same, they could be different. Most likely they were different. And then we added in one 125, another in 250 ml. But what I am having difficult here is I would like to see the colors just like this. The 125 should look like this and 250 should look like this, because you add more, it's going to get diluted, right? Now I do not know why it is like this. It is.
Instantly all the water got to the bottom, drained out for 125 because there were cracks in the sides. 125.
The soil also came out.
Sir, this might be a reason. There might be a reason that the initial one was not at its container capacity.
Okay.
So we have only.
So let's do this. Let's
So we can run it through a filter before.
no, let me think. So which one is 125? Sorry.
This.
Okay. So this is 125, right? Why don't we throw this away and then pour 250 on this one? Okay. Same thing, and let's see what it looks like. Should be one more bottle over there. Slowly, entire part.
Not at its order.
पूरा डाल दे 250 पूरा डाल दे
So that's going to now push down everything, and
इसमें से 125 मिलेगा.
नहीं ये तो 125 ना, and I'll take that. That's my drinking water.
That just scares me so much.
No.
We have plenty.
You utilize a lot of pressure.
नहीं we're going to keep it.
125 इसका था पहले
अब 250 आ रहा है. Yeah.
250 डाला है वो क्या टूट रहा है तो इस वजह से मिट्टी पानी आना सब आ जाएगा साथ में
Cracks. There might be some natural calamity. Cracks.
Tabletop. Ah, now. There you go. She has the nice ones. You can measure from there. Ah.
EC 462 आ रहा है माइक्रोसाइमन
Yeah.
पर सेंटीमीटर
0.46 millisieverns.
Fresh water चाहिए.
Why don't you test in fresh water too? So you should get close to 0 for fresh water.
उस बॉटल में डाल लो. नहीं आएगा.
नहीं मैं समझ गई क्लीन कर रही हूँ
डाइल्यूट हो गया वो.
ये वो तो हो गया ना इसका काम तो
इसी
ऐसे तो करना था 125 डाल दिया
ये चीज देख
ये नहीं मिला था पूरा लिख रहा है वो इसी कितना था
0.4
लेकिन वो बहुत
अरे कुछ आएगा नहीं ना आपको दो
अरे उसका ढक्कन नहीं है
माइक्रोसाइमन
No cups नहीं है. तो ठीक. हाँ.
फाइव 1.6 माइक्रोसाइमन
ये तो और ना
वाला पानी डाल
अरे वो तो
जरा वाटर डाल के पानी डालना पड़ेगा
मिनरल वाटर भी ज्यादा है.
वो नहीं है ना वो तो वाला पानी है ना आपका पानी
हाँ तो ये भी तो उसी का है. आरो वाला है
ये बॉटल तो अलग है ये वाला
ये
पानी
नहीं ये वाला है ना. ये तो इसका चेक कर लो ना सर.
सर कैन यू प्लीज फॉलो दैट
Yeah, please. No worries. You can. आप अंजलि से बात कीजिए कब इसको फर्टिलाइजर के. मे बी मंथ्स बैक. इस 5 में नॉट एनी फर्टिलाइजर.
सर 1 month. 1 month है.
Understood.
कैप
170
But we should see that. But that 250 वाला निकला क्या? So we'll try that. So the RO water is what, 170, and then the 125 ml was like 450. Do you want to try one more time? You want to measure?
हल्द्वानी का पानी लाया था कल चेक करिए
So you can also measure pH also.
pH
Now it's 50450.
So it'll vary a little bit. That's normal. So that's only EC, or do you have also pH?
What's the cost of these sensors actually?
It is actually I bought for myself about they're not that much expensive. Still not.
TDS meter है ना इसी मीटर सर्च करो आप just check the सारे arrange में जाएंगे जब भी 20,000 फिर आरो लगाने वाले आते हैं ना वो भी
उनके पास भी यही होता है
उसमें सब कुछ है
ये वाला यूज करते हैं नॉर्मल क्या आपने कहा
Sales is only 300 rupees discount.
So these instruments might vary or
Every bit of instrument is going to be different. That's why you calibrate.
in these we don't need any calibration.
No, you have to calibrate that, but I don't know.
No, they are calibrated.
The cost of the equipment depends upon the electrodes. That's the major part. Electronics are now a little bit cheaper, but the electrodes and the electronics inside affects the cost. If you have a nice, very sensitive bulb, that's more expensive. So companies can come up with a range of sensors, but it's all about how sensitive the electrodes are and what type of electronics they have used. What happens with electronics is that they have to measure the voltage there, and are they measuring voltage to 1 decimal, 2 decimal, 3 decimals? That's what affects the cost of the electronics.
does they use rare earth
Sorry?
rare earth
What is it?
Rare earth metal.
Rare earths. I don't know what they use. I have no clue. Yeah, I have to check. So pH, how much is pH?
Decreasing.
Yeah, it's a highly variable, but in that range, right? Okay.
Alkaline. Slightly neutral alkaline.
And usually you drink water that is in that neutral range. You don't want to drink acidic water, right? So while that is still getting a steady state value, what we can do is we can transfer. Can we? Do we have?
There's still water in.
Okay. Well, if we have collected some water that's good enough for us to make a measurement, let's do that. It should have a diluted value than the 125, right?
What may now do?
Now let's see the EC and at least EC and pH of these two. What are we measuring? Are we measuring EC or pH?
pH.
Let's measure the EC too if we can simultaneously. Three seven and okay, can it, 460 and 37 so dilution. So the more water we add, more diluted. Basically, what we are measuring is what we are adding, rather than what we are pushing. And we don't know even 125 is accurate, right? We just added 125. Maybe 50 ml is okay, right? So the more you add, less diluted, simply because we are adding water, RO water, which has got, I don't know whatever that is, 17. Well, you measured 175 or something, right? So you're adding dilute water, so that is coming through. So very important concept with pour through is to figure out what is the minimum amount of water you should add, so not excess water is coming out. So because that is 175, we're getting 450 here, naturally you'll get less there because you have added too much water. But in any case, yeah, for pH. And you will see there is an inverse relationship between, it depends on the fertilizer, but I will say you would expect the same pH here, right? It won't be, because EC also affects pH. So if you measure in here, you may actually see either higher or lower depending on the ions. Would you please measure the pH in this one?
7.7, around 7.79.
But that's still within the margin of error. So you can buy simple sensors like 7.6. Yeah, as the PC is going, in this case, probably the pH is also going to go up. Yeah, 4, something like that. So again, those two are interrelated, and so absolute importance is to know that. So for example, if you applied 100 ml and you are getting all the 100 ml back in that means you are actually applying too much. So usually when you apply 100 ml, because we won't be able to bring the parts to container capacity 100%. There's still some areas where the water can be added. So if you apply 100 ml, you may only get 50 ml down there. That is kind of okay. But if you are getting all the water back, that means probably too much. We're adding too much. I would say for these parts, maybe 75, 50 ml is more than enough. And then that is what we have to use to measure. This is a trial and error method, so don't worry too much. But this is the way you pour water out and measure it. This is an accurate measurement, but it's too slow. That's why we go for in situ probes that you can insert. But if you're using clay soil like that, even that probe may break because it's so hard. So you have, but those in situ probes I've shown you, they are good for soilless substrates. You can easily insert. Yeah, but they look easy. This is giving you pour water EC. Okay, that's the difference. To bringing that, thank you very much. Yeah, I think the other units are broken. No, the bulb is broken. We found one of them as a broken bulb, so the electrode is gone. So you may have to change the probe. I don't know whether you want to, but it's pretty old, isn't it? Pretty old, so you may want to just throw it away.
Sir, ये भी possible है कि वो रखा हुआ हो unused.
Yeah, they should have sent some working.
It's not working, it needs servicing. It's not working nowadays because it needs servicing.
But even this is not working.
It shows both readings, that
pH and EC.
Ah.
that meter also.
I see, but it's not working.
That's why they have purchased their.
Yeah. Yes, please. Well, I will make sure we'll spend 2 hours looking at all the sensors, but on the Zoom. Okay, so you can ask the student all the questions in Hindi, and she can also explain to you. But I felt like seeing them in person would be nice, but unfortunately, thank you, ma'am. Thank you. But in any case, yeah. Did anybody inquire about those light sensors? Somebody was trying to. I think she is not here, but that's okay. I think we'll leave the sensors and automation to Zoom class because that's probably the better way. They're all using it and they're working, so we'll deal with that. Yeah, again, keep in mind with EC sensors, calibration is absolutely important. If you don't calibrate, it's no use. The bulb is the most sensitive part and it can break if you don't pay attention. Even those probes that in that box, they should have come with a cap. The cap is not there. That's one reason why the bulb is exposed and you can break it. People sometimes put the probe in the beaker and do like this, and you can break the bulb. You were trying to inquire about quantum sensors, light sensors, right? They don't have it. Okay. Well, we'll leave all the sensors and automation to Zoom class. I will we'll do a 2-hour class, and you can. Huh? You may not find them, right? It's okay. Even if we don't find, let's not.
There might be a possibility that buffer tablets might be old, so that instrument was not giving accurate pH also.
If a sensor gives the same number everywhere, it means it's the problem with the electronics, not with the buffer, right? It's giving the same number. You tell me it's giving the same number. That's problem with the sensor. The unit's bad. They are from 60s and 70s. I have some of. So when I originally went to Purdue University, they gave me a lab. They said, this is your lab. Okay, I moved out of that lab, but I found a lot of old equipment. The previous professor was from 1950s there. So he retired and then I occupied that place. But there was one EC meter like that. The one that they brought, it was exactly like that. What we do is we take those EC meters and we put it on a shelf, like, for a showpiece. They don't work, but it's just the thing is, you can make them work, but it is less inefficient. Rather go for newer technologies, much more effective. But I don't know what you found out, right? So they have two probes. One is a EC probe and there is a temperature probe. So when you put it in the automated mode, then only it actually measures the temperature and then takes that value and adjusts the EC value for the temperature compensation. So it's absolutely important. Temperature is one thing that almost always affects EC, pH, dissolved oxygen, all those things, even volumetric water content also. Okay. Any questions? We have some time. Do you want to run that quiz now? Yeah, you've been. So how do you want to do that? I'll just sit there. Okay. So why don't you explain what you're doing, because not everybody heard it. So first explain what you're doing and then bring it on. Right there. No worries.
Sorry.